An extended implementation of CLI developed by Microsoft. This application programming interface API is cross-platform and can be used to access any DBMS or DBMS server that has an ODBC driver. This enables a software developer to build and distribute an application without targeting a specified DBMS. Database drivers are then added to link the application to the client's choice of the DBMS. For example, a microcomputer running under Windows can use ODBC to access an Oracle DBMs running on a unique box. There is a considerable support for ODBC. Application vendors like it because they do not have to write and maintain code for each DBM. They can write one API. DBMS vendor supports ODBC because they do not have to convince application vendors to support their product. For database systems managers, ODBC provides vendors and platform independence. Although the ODBC API was originally developed to provide database access from MS Windows products. Many ODBC drivers vendors support Linux and Macintosh clients. Most vendors also have their own SQL APIs. The problem is that most vendors, as a means of the differentiating their DBMS, have a more extensive native API protocol and also an extensions, the standard ODBC. The developer who is tempted to use these extensions threatens the portability of the database. ODBC introduces greater complexity and processing overhead because it adds to place of software, as the following figure illustrates. An ODBC compliant application has additional layers for the ODBC API and ODBC drivers. As a result, ODBC APIs can never be as fast as native APIs. ODBC layers, application ODBC API, ODBC drive manager, service provider API, driver for DBMS server. DBMS server enable embedded SQL. SQL can be used in two modes. First, SQL is an interactive query language and Database programming language. Select defines queries, insert, update, and delete maintain to a database. Second, an interactive SQL statement can be embedded in application program.